Hey the guinea pigs, I'm back to the lab. So you remember last video we didn't fix an Oric Atmos, we fixed actually an Oric one. So I promised we will fix this Atmos and that's what we'll do in this video. You remember this poor state, right? It could not boot. Even if you try to reset it manually, like I did with the Oric one, it was just like looping back to this corrupted screen. The first thing I wanted to show you is actually a good point where you can hook up your logic probe. So on the keyboard interface, you have two pins, the 10 and the 16, that are the 0 and 5 volts. So that's where I'll hook up my logic probe. So with the Diag ROM, if the test fails, you can get the feedback from the Diag ROM from the address lines. So here, I check the address line from A0, A1, A2, and so on, right? And you see that I have like pulsing, low, high, low, 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 low. So if you look at the manual from the Diag ROM, it means that basically the quick RAM test failed. The Diag ROM tries to use the first bytes of the memory, and that didn't even work. So it just fails right at the beginning. So it means that something's wrong in somewhere, either like a RAM, but I've checked all the RAM chips, or anything between the CPU and the RAM. Could be the ULA, but the ULA, we tested it with the Oric one, it was working. So I started to suspect this one, the IC21. Which are the RAS and write control for the RAM. If you remember from my last video, I actually took from an old PET part, actually, this LS04. So let's replace that with a brand new one that I'm sure it works, right? And trying it out, it actually didn't work. So, okay, the next thing, between the ULA and the RAM, we have also those two ICs, the IC8 and the IC20. I first check with the logic probe if every single output from those two chips that are actually basically multiplexers, right? They enable actually the ULA to be able to use the RAM for the video and block the read and write from the CPU at the same time, right? It's just like a kind of a bus arbitration IC. So my working hypothesis is that it should be like a little bit like uniform, right? And I saw that yeah, those were not actually. So I started to suspect them. So I took my desoldering iron and just remove them. From there, I used the Mini Pro software that has tests for those ICs, right? They were both testing normal, right? So I was back to square one, and I took a serious look at the PCB, and I realized that I missed one solder point on the RAM. Oh my god, all that work for nothing. Anyway, I just soldered the couple points I missed and tried it again, and it didn't boot. So I used my regular like reset technique that I used on the Oric one, and look at that, the test passed. Basically, I just had to change the RAM, and this Oric Atmos was working fully. Now I know. Anyway, so let's try with a basic ROM. So when it boots, it goes to this like a zebra screen and locks there, right? It was not the same behavior as the Oric one. But when you actually do the manual reset procedure, it goes to the basic. So you know what I need to do, right? I need to apply the 83B modification. It worked. Okay, let's try the the keyboard. So I tried quickly the keyboard and everything was working. I was like ecstatic. Yeah, it's just like it's gonna be, that's the end, right? It's gonna work. So now let's clean up, right? Like let's make it pretty. So I remove everything, the motherboard. Then I remove the keys one by one from the keyboard. So very carefully at the beginning, right? I didn't know that the switch type from this keyboard, and they are the ones that I recognize from the TI-99. So yeah, once I removed one, I was pretty sure it was safe to remove them. You can even remove them without a key puller. I use my big anti-static brush to remove all the dust that accumulated behind the keyboard. Then I use some water with some dish soap, simply. You can use also regular soap. And my trusty toothbrush. Let them soak for a little bit. And then one by one, I basically clean them up with my toothbrush. It takes a while. Just cue in some nice music, and you're good to go. Then same treatment for the case itself, right? First the back, and then the top. I really try to go to all the nooks and crannies on the case. Then I rinse them with fresh water. Dried up the case with a microfiber cloth. Same for the keys, and I put them all aligned for some treatment. So I use a 303 aerospace protectant. That's something I learned from Adrian's digital basement, right? It's a product that makes the plastic kind of pop in terms of color, right? And protects them against UVs. So it's good for like plastics you want to restore in general, right? So you soak them. But you should not wait with the product applied. Quickly go in and wipe them all pretty clean, very, very dry. And they looked absolutely gorgeous. So let's go to the case. For the case, I choose another product I have, which is like, it is a car product. to restore plastics, because I noticed that there are some scratches on the top of the Oric. So this plastic polish can actually remove little scratches like this. You can do some circular rubbing like this to remove little scratches and make the surface completely shiny. Then you need to put back the keys one by one. So again, cue up some nice music. Usually I take a picture of the keyboard before doing this, and you put them back one by one. Okay, time to put back that in the case. The keyboard first. Then the motherboard. Let's remove all those check marks from the components. I like to restore that a little bit like it was. And finally the back case. Oh, but I noticed that it doesn't fit anymore. Damn, that's because I socketed the 6522 at the bottom of the motherboard, right? And the little plastic ergo, right, that is actually holding the motherboard is too low. So I just went on and removed it. And it fit snugly. So cool, right? Now we have an Oric Atmos fully working, right? Wait a second. The keyboard doesn't work anymore. Oh my god. Okay. So let's take this opportunity to do like an impromptu deep dive on how keyboards work. So you could imagine like a keyboard is like a bunch of switches, right? What you could imagine also is like maybe you could have the computer have one I/O pin per key, right? Like basically, if you press the key A, it would short the I/O number 1 and B number 2 and so on, right? But that's a lot of I/Os for a computer, right? And usually you don't press several keys at the same time. So usually when you design a keyboard, you put that in a matrix. So imagine instead of like having I/Os pointing to one specific key, you have I/Os pointing to a row or a column, right? So basically, instead of let's say 64 I/Os, now you need 8 plus 8, 16. That's amazing, right? You saved a lot. But you can do a little bit even better, right? Now you imagine your row and columns, only one of them can be activated at a time, right? Or roughly, let's say. So what you can do is you can optimize by basically converting those rows or columns from one bit to a number. You could say that's the bit number 3, for example, right? And that you convert that in binary, right? That's what this IC 4051B is doing. Basically, it's taking the rows, right, as 8 bits and converting that as a number in binary over 3 bits, right? 3 bits makes from 0 to 7. So you get your kind of like an even more compressed way in terms of number of IOs. Right? So okay, let's look at how it looks like on the keyboard itself. So let's try first the one key, right? It works. Then let's see where it goes. So it's row 0, right? So pin 13 of the 4051B. And if I trace it from the other side, it goes all around the keyboard, which is normal, right? It goes through all the related keys that are on the same row, and it goes back to pin 11 on the column number 5 at the bottom. So yeah, my keyboard seems to work. I checked like few keys that were not working, so there is no problem in any of the traces. So I started to suspect the cable, right? So I tested all the connections one by one until here I found one that didn't work. So I was like, what's going on? I started to look around. I noticed that, yep, the cable actually is totally splitting apart from the keyboard. Oh my god, that's our problem. So let me present you my nemesis, the DuPont connector kit. So those things allows you to make like custom connectors. So here I try to mimic the connectors that is on the keyboard, right? I do that with like 2 parts. I didn't have like a DuPont connector that was long enough. So first I remove all the ends of the cable that stayed soldered on the PCB. So I just use like very old tweezers for this, right? Don't use your good tweezers. Then once they are cleaned up, I use my desoldering iron to clean up the holes, right? So then, my nemesis, the crimping tool. So what you want to do is to basically get one of those end metal pieces, right, in the crimping tool, and insert the end of your cable, right, and just pinch that, right, without pinching the active part that is on the pins. Then I noticed something. When I counted the connectors, number of conductors on the connector and on the PCB, they are not the same. Actually, they were off by 1. I needed 14 instead of 15. So, okay, cool. I stripped the wires on the PCB side. Then twist them. Then, just to ease the work, I just put some solder on them so they are easier to actually insert. Finish all my DuPont connections. Then solder it on the PCB. Clean up all the soldering mess. And finally, out of those 2 connectors, I just link them with some transparent tape. I just use like regular, strong, transparent packaging tape. I really like this tape. I did that on both sides, so it's quite solid, it works well. Alright, then time to test it again. And guess what? It did not work. So I'm back again on this keyboard and I tried directly the connections, right? Like between the multiplexer and the connector, right? Tried few of the keys that didn't work and they worked. So I was really confused because like I just replaced the cable and the keyboard is still working, so don't know what's going on. So tried again to check for the cable, and you know what? Sure enough, some cables were broken. And it started at the connector with my bad crimping job, but I noticed it also on the PCB side. So you know what? I redid a cable. I applied like a, let's say like a Chinese technique that I saw on some toys, right? Where they put some hot glue to make a kind of stress reliever for the cable. And it worked well this time around. So this time, the entire keyboard was working. It took me a while, I tell you. So I put all that back together. And it looks pretty good. So I tested the keyboard. The keyboard is an actual, like, real pleasure to use. So you know what, my guinea pigs? I think it's time to cue up some music and let's take some nice shots for the machine. It's gorgeous. So thank you for watching this part 2 for the Oric Atmos. I promise you there will be a deep dive into the machine itself. So let's do a part 3. If you don't want to miss out, please subscribe, click the little bell so you get one when the video will pop up. And yeah, as always, feel free to leave a comment in the comment section below.